Okay, so good day sa inyo lahat. So we will discuss the chapter 2 of our lesson. So what we call the strain. Okay? Okay. By the sigma epsilon. Okay? So una, yung pinaka-strain, okay, so na-measure natin siya when it comes to the deformation. Okay, for example, mayroon kang bar, tapos loaded siya by a tension, hinihila mo siya. So technically, pag sobrang hila mo dyan, kahit napakaliit lang, magkakaroon yun ng deformation, no? So yung deformation natin, okay, we have this symbol, okay, and that is the delta, the small delta, okay. So this is strain, okay, meron kang original length, so that is equal to deformation or over the L, okay, or in the L, it is the original length of the cross section, no? For example, meron kang isang bar dyan, okay, tapos hinila natin by a force P, okay, so technically yung force P na yan, it will induce a deformation, okay. So eto yung kanyang deformation, and then eto yung kanyang original length, okay. So yung strain mo is computed using the deformation over the original length, okay. And then this stress and strain, dahil meron kang P tapos meron ka namang A, okay, meron ka rin makukuhang stress, okay. So that is the P all over A, normal. I am speaking for the normal stress, no. It is then plotted, okay, pinaplot natin siya sa ating tinatawag na stress and strain diagram, okay. Pag-usapan mo natin sa stress and strain diagram. So basically, kung lumalaki yung force mo, lumalaki yung stress mo, okay, kasi maintenance na lumalaki yung force mo, lumalaki rin yung deformation mo, lumalaki yung strain mo, okay. So there comes a time that this one, okay, most of the material is merong tinatawag natin sa graph is a straight line, okay. Yung point natin na to, ito tinatawag nating proportionality limit, okay. This proportionality limit, okay, ibig niyan sabihin yung stress mo daw at saka yung strain, kung papansin niyo, they are constant, straight line, okay. So you have there a straight line, okay. This follows what you call the Hooke's law, okay. Yung Hooke's law natin hanggang dun sa proportionality limit, okay, meron yang for example, yung vertical mo is the sigma, and then yung horizontal mo is the what you call the strain. Yung kanyang tawag natin dito, yung kanyang slope, okay. So you have there your slope, okay, that is rise all over run, okay. So yung rise natin dito is our sigma, and then yung run natin is our epsilon or our strain, no. This one is what you call the Hooke's law, okay. Diyan nakukuha yung tinatawag nating modulus of elasticity, okay. So yung modulus of elasticity natin, hindi yan buong graph ng stress and strain diagram applicable, okay. Applicable lang yan lagi dun lang sa part na merong straight line or yung tinatawag nating proportionality limit. Kasi kapag nilakasan mo pa ng hila yan, okay, just above the proportionality limit, magkakaroon na yan ang tinatawag nating elastic limit. So itong elastic limit natin, okay, let's call it as elastic limit, okay. Ito yung point or yung stress dun sa material or strain dun sa material na kapag tinanggal mo yung load, babalik pa siya sa original position niya, okay. So for example, nilagyan, hinila mo, tapos madedeform yun ng kaunti dahil basta nagkaroon naman yan ng force, meron yan deformation. Pero upon unloading or tanggalin ng load, babalik yun sa original position hanggang hindi niya nare-reach yung stress na to. So ang tawag natin doon is elastic limit. However, in some materials, hindi kasi pare-parehas ng behavior ang material. Minsan, si elastic limit tsaka si proportionality limit, they mostly coincide. Okay? They mostly coincide on one point. Okay? Just above the elastic limit, kaunting-konti, lakasan mo pa ng force, may tinatawag na tayong yielding. Okay? Yielding stress. Okay? Si yielding stress, dyan na, pag lumagpas ka na dyan, magkakaroon ka na ng deformation. Okay? Ang tawag natin doon is the permanent deformation. Tawag natin is actually the plastic deformation. So, hanggang nandun ka lang sa yielding stress or beyond yielding stress, babalik ka pa sa kanyang original position. Okay? At an appreciable amount lang. So, maliit na maliit lang. Okay? Ngayon, si yielding stress, pagdating dyan, somehow, yung ibang material, nag-i-straight na siya ng ganyan. No? Okay? So, yielding stress. And then, naangat yun ng kaunti pa hanggang ma-reach yung pinakatuktok ng stress and strain diagram. Ang tawag natin dito is the ultimate. Okay? Ultimate stress. Okay? Ngayon, pag nilakasan ko pa ng nilakasan yan, okay, babagsak na yan hanggang sa maputol na yung pinaka-bar mo. Ang tawag na natin doon is rupture stress. Okay? So, you have there the rupture stress. Okay? So, iyan yung parts ng ating ang tawag natin dito. Iyan yung part ng ating stress and strain diagram. Dito sa part na to, okay, yung part na to, kapag nandyan na yung pinaka nandyan yung pinaka force natin, alam niyo yung tira-tira dati, yung matamis na pahaba na tapos kinakagat mo tapos hinihila mo ganun, okay, pay yung straw pag hinila mo ng kaunti. Kapag yung pinaka-straw nun o yung pinaka-tira-tira nun, lumiliit yung diameter, pero hindi pa siya napuputol, lumiliit pa lang siya, umahaba siya tapos lumiliit. Ang tawag natin doon is necking. Okay, dito yun sa part na yun. So, na-reach na yung ultimate strength. Ibig sabihin, magkakaroon siya ng plastic deformation. As well as, humahaba na yung kanyang material. Tapos, lumiliit na yung diameter niya. And then, hanggang sa maputol na siya. So, that is what you call the necking. Okay? So, for this chapter, we will discuss on how to compute for the deformation and how to compute for the strain and different parts of the strain diagram. Okay? So, let's start. So, dun muna tayo sa pinaka-simpleng, okay, pinaka-simpleng example. A steel propeller shaft ABCD carries the actual loads shown. Determine the change in the length of the shaft caused by these loads. Use modulus of elasticity E equals to 29 times 10 to the 6 PSI for steel. Okay. Yung pinaka-deformation natin, by the way, we have a general formula for deformation equals to PL all over the AE. Okay? Wherein the P, it's actually the internal, okay, so that's the internal normal force, okay, wherein the L is the length of the member, wherein the A is the cross-sectional area, and your E is the Young's modulus of elasticity. Okay? So, again, dapat dyan, kung titingnan natin, ano muna yan dapat, in equilibrium. So, check nyo muna kung equilibrium siya. 6 to the right. So, 4 to the left, equilibrium siya. Okay, so pwede tayo mag-cut in any section. So, kapag hindi, dapat yan may support. Okay, anyways, later on. Okay? So, what we will do, okay, ang ginagawa natin, parang dati, pagkuha ng stress, kinakat natin section per section. So, pwedeng right or left. Okay, unahin ko muna tong section AB, no? So, ikakat ko siya. Okay. Okay. Tapos, meron siyang diameter. Let's see, okay, that is a diameter, no? Tama ba sabi? Determine the change in time. Okay, shaft. Okay. Okay. So, dito meron akong 2,000 pounds. Okay? Ngayon, para maging equilibrium yan, magkakaroon ako ng internal force dito. So, that is around 2,000 pounds also. Okay? So, this is now the PAB. Okay? We call it as PAB. And kung papansin niyo away from the section, this is tension. Ibig sabihin, if the shaft experiences a tension, and then we will be having an elongation. Pag naging compression siya, ibig sabihin, shortening naman siya. So, we will be having here a minus sign for that. Okay? So, to solve for the deformation of the AB, so you will be having here PAB, LAB, all over AE of AB, no? Okay? So, we have P, 2,000. Ang L, okay, kasi maliit lang yung mga deformation, maganda niyan, i-inches nyo na. So, yung L natin is 5 feet. Okay, gawin na natin inches, so multiply ko na by 12. Okay? So, ang AE diameter is 0.5. So, pi all over 4, multiply it by 0.5 squared. And then E, kasi, ayan, PSI pala, so dapat naka-inches siya talaga. Okay, so 29 times 10 to the 6. Okay, in pounds per square inch. So you will be having here 2,000 times 5 times 12 all over pi over 4 multiplied it by 0.5 squared times 29 times 10 to the 6. Okay, or you have here in 3 decimal places kasi masyadong maliit ang mga deformation, 210. So you have there the inches. Okay, next, i-cut ko naman dito at section B. Okay? Tapos mamili ako, right or left. So, sige, ano na lang ulit. Left na lang ulit. So, this is the first section. And then, ito na yung aking section B. Okay? So, again, meron ako ditong 2,000 pounds. Okay? Wala namang ibang other forces. So, to gain equilibrium, again, this would be also 2,000 pounds. Okay? And this is now your PBC. Okay? So, we will be having deformation of the BC equals to P, 2,000. L is 4, kaya lang gawin na nating inches. PL all over A. So, pi all over 4. Ang A natin is 0.75 squared. And then E of 29 times 10 to the 6. Okay, so we will be having here deformation 2,000 times 4 times 12 all over pi over 4 times 0.75 squared times 29 times 10 to the 6. Okay, so you will be having here yan 0.007 for sige 0.7 inches. Okay, next, lastly, yung C, cut ko rito. Mamimili ka ulit, right or left. Pero this time, mas gusto ko left na lang, ano, para mas maikli. So, we will be having here this one. Okay. And then, meron ka doon compressive force na 4,000 pounds. Okay. So, para maging equilibrium, kailangan ko dito ng equilibrant force. So, that is also 4,000 pounds. And then, this now is your CD. Okay? So, the formation ko ng CD, that would be negative. Okay? To denote that it is a shortening because of the compressive force. So, P, ang L ko is 4 times 12 all over pi all over 4 multiplied by 0.75 squared, and E is 29 times 10 to the 6. So, we have here the elongation C. Okay, so that is 4 times 12. So you will be having here negative 0.015 inches. Okay? So the total deformation of the shaft, that would become deformation from AB plus deformation from BC plus deformation from CD. So AB is 0.021, BC is 0.007 plus or minus 0.015. So you have a total deformation 0.021 plus 0.007 minus 0.015. So the total deformation is 0.013 inches. Okay? So the shaft deforms by 0.013 inches. Okay? So, sige. Kopya. Okay. So let's have this problem. The cross section of a 10-meter long flat steel bar AB has a constant thickness of 20 millimeters, but its width varies as shown in the figure. Calculate the elongation of the bar due to 100 kilonewton axial load and use equals 200 gigapascal for steel. Okay, so this time, wala tayong problema, may L tayo. Madali lang kunin yung P. Ang problema natin is yung A. So, A varies from 40 mm to 120 mm. Okay. So, ang gagawin natin, para tayong kukuha ng isang cross-sectional area. No? So, at this distance X, I will try to get for this cross-sectional area. Okay, yan yon. Okay, eto yung 20 mm ano. So, parang nakaganon kasi siya. Yan. Kumbaga, yun yung thickness niya eh. Ayan, parang nakaganyan yung thickness niya. ganyan yung thickness niya, no? Okay. Kukunin ko yung area na yon. Though, mahirap kuhanin yung area, it is because tapering siya. Pero, gagamit tayo in terms of, sabihin na nating variables. Okay? Na, i-search ko ng kaunti. Okay. Sample. Ayan. Okay. You'll be having this one. Okay. Ito, automatic to, 40 mm, ano? 40 mm. Okay. And then, kuha ko dito ng line. Kuha ko doon ng line para automatic to 40 mm. Okay? 100 mm yon. So, ito, tig for 40. Kasi 80 na lang matitira. No? 120 minus 40, 80. Divide mo by 2. So, 40 mm din to. And this one is also 40 mm. Okay? Ngayon, at any cross-section, okay, kahit saan, for example, dun sa line of X natin, okay, this is 40 mm, constant. Ito hindi natin alam. Okay, but they could be equal, tawagin ko yung Y, and then tawagin natin yung Y. Okay? So, kumbaga, from here, okay, ito yung aking Y direction, tapos ito yung aking X direction. So, at distance, X. Okay? Hindi natin alam yun. So, kumbaga yung cross area natin is 40 plus 2y multiplied it by the value of thickness. Kasi yun yung thickness mo eh. Around 20 mm, ano? Okay. So, ito yun yung ating cross-sectional area. Okay? Kaya lang, kunin natin in terms of x by using the ratio and proportion. Using ratio and proportion. Okay? So, kumbaga yung malaking triangle ko, yung distance niya, total distance niya from here, and then that is around 10,000, ano? So, you have here 10,000 mm. Okay? Using ratio and proportion, okay, dun tayo sa malaking triangle, okay, yung height niya is 40, and then yung length niya is 10,000. Okay. Yung sa maliit na triangle, we will be having here, ang height niya is y, at x niya ay yung maliit. Okay? So, we will find the value of y. So, y is 40 divided by 10,000. So, that is x all over 250. Or, that's around 4 times 10 to the negative 3 of x. Okay? So, kung kukunin ko yung aking isang area, okay, iyan ko yun, 40 plus 2y. Kaya lang ang y ko is x all over 250. Okay, and then multiply it by the thickness of 20. So, simplifying, we can have it as 40 plus, okay, x all over 125. Multiplied it by 20. Okay? So, yan. Ngayon, ilagay na natin yung pinaka force natin, ano? So, yung force natin is 100 kilonewton. So, gagawin natin yung newton. So, you will be having here 100 times 10 to the 3 newton. Okay? Ang L natin dito, ayan, naka-drawing na. Okay? Kinat ko, no? Kasi nasira, may tumawag eh. Okay? So, we will be having here this one, your dx. Okay? Kasi representative element ka lang, representative area. So, you have here the dx. So, yun yung pinaka-length mo. So, that is dx. Okay. Ang a natin, again, 40 plus x all over 125 multiplied it by 20. And then, ang e natin is the modulus of elasticity. Kaya lang naka-gigapascal, dapat naka-megapascal, no? Para newton per millimeter squared. So, you will be having here 200 times 10 to the 3 para maging megapascal siya. Okay? Kaya lang, yung dx mo, it runs from x from 0 hanggang sa x ay 10,000 millimeters. Okay? So, lahat ako naka-millimeters, ano? At saka lahat naka-newton. So, 100 times 10 to the 3 all over 40 plus x all over 125 multiplied it by 20 times 200 times 10 to the 3. Again, that runs from 0 to 10,000. Okay? So, hintayin natin yung sagot. This is now the total deformation. So, with this, kapag yung isang cross-sectional area mo ay constant, okay nang gamitin yung PL over AE. Pero kapag ang cross-section mo is varying from one point to another, you need to account for the change in the area and have the integration on that. Okay? So, ayun, may lumabas na sa calculus. So, that's around 3.43 millimeters. Okay? So, this is now the answer for this problem. Okay, sige po. Kopya mo na. Okay. So, let's have this problem. The rigid bar BC in figure A is supported by a steel rod AC and cross-sectional area of 0.25 inches squared. Find the vertical displacement at C caused by the 2,000 pound load. Use equals to 29 times 10 to the 6 psi for steel. Okay. Una, sinabi naman sa problem na rigid bar si BC. Okay, what does it mean? Kasi in reality, dapat yan, okay, kung hindi siya rigid, may tendency na pati ito ma-deform. Okay? As if na parang ganda. Okay? So, lahat naman yan na-deform. Kaya lang, bakit sa problem or sa mechanics sinasabi na rigid bar? Rigid bar siya in a way na in comparison to the deformation ng AC. Okay? Isipin nyo, ito tabla o kaya tubo. Tapos ito, isipin mo rubber band lang yan, di ba? So, konting pull mo lang dito, ang unang madedeform excessively yung pinaka-rubber band mo dito, yung which is the AC. So, in comparison, yung elasticity ng AC doon sa BC, di hamak na kitang-kita mo na yung deformation doon sa AC bago pa man ma-deform si member BC. So, parang ang term is negligible yung deformation ng BC in comparison dun sa deformation ng AC. Kaya rigid bar siya. So, we expect na kapag bumaba or na-deform to, dapat straight line pa rin si rigid bar, si BC. Okay? So, with this, ang pinakauna nating mangyayari, okay, paano man natin deformation, ano? Okay, ang una nating mangyayaring we could have it the force on the member AC. So, kukunin natin yung member AC for that. Okay? Pwede ako mag-joint doon. So, this is my joint C. Okay? And then, meron ako ditong 2,000 pounds. Okay? And then, technically, meron ka dong tension. Okay? So, you will be having here the tension on the AC. Okay? And then, here, meron ka ritong reaction, syempre, from the BC. Okay? So, pwede ako mag-summation forces. Vertical equal to 0. So, this one is 40 degrees. So, I will be having here TAC. Okay? Sine of 40 minus 2,000. And that would become equal to 0. So, you will be having here TAC. So, that is 2,000 divided by sine of 40. So, you will be having here 3,011.45 ano yung unit nito? Pounds. Okay. So, meron na ako ngayong TAC. And TAC is actually, okay, that is, ang tawag natin dito. Iyon yung pinaka-force na natin. Okay? Next. To solve for the deformation of the AC, so we will be having a formula PL all over the AE. Okay? Ngayon, ito 8 feet to eh. Okay? So this one, this length would become equal to 8 divided by cosine of 40. Okay? So length ng AC natin is this equal to 8 divided by cosine of 40. So that is around 10.443 feet. Times na natin by 12 para maging inches. Okay, so you will be having here 125.319 inches. Okay? So P 3,111.45, L 125.319 all over the A. Okay, binigay na naman yung A, so that's around 0.25. And then the E is 29 times 10 to the 6. Okay? So, meron ka na ngayong deformation AC. So, that's 3,111.45.319 all over 0.25 times 29 times 10 to the 6. Okay? So, you will be having here deformation 0.05378. Okay? Kaya lang, okay, tingnan natin kung paano siya ma-deform. Kasi kapag na-deform, so you will have 0.05. Okay. Pag iyan ay na-deform, okay, bababa ito. Okay? Kasi sabi ko nga kanina, i-exage ko lang, yung pagbaba niya, okay, syempre dapat 8 pa rin yun. Okay. So, let's say ganyan yung ano natin, sobrang liit lang naman nun. Okay, so sometimes sa mechanics, okay, kapag bumaba siya, ayan, something like that. Okay, tapos eto na yung magiging parang from A to C. Okay, let's call it C prime kasi dyan na siya manako. Parang ganyan yung magiging deformation niya. Okay, ganito yung isang technique kasi sobrang liit lang ng deformation, so by symmetry ang ginagawa natin, okay, na-deform siya, ito yung parang magiging deformation niya. Okay, hahaba, yung AC humaba. Yung deformation na yon, yun yung inyong 0.05378 inches. Okay? Ngayon, yung pinakabagong point doon, okay, pwede kang kumuha ng perpendicular doon sa kanya. Okay? So, that is the deformation. And then, if this is 40 degrees, this is 90 degrees, okay, 90 degrees, 180 minus 90. So, 90 minus 40. So, this is 50. So, eto dito mapupunta yung ating 40 degrees. Okay? From that deformation, 0.05, para ka ngayong merong isang triangle na nakaganto. Okay. So, let's have it. Oop. Para ka merong nakaganyan. No? So, eto yung point C. Eto yung C prime. And then, eto yung deformation mo na 0.05378. And then, eto yung ating 40 degrees. Okay? Ito ngayon yung vertical deflection na hinahanap. So, ang hinahanap kasi is the vertical deflection. Okay? So, vertical deflection at C prime. Okay? So, para makuha natin yon, kukunin lang natin yung component niya. Okay? So, if we need that 40 degrees, ano kayang, pwede? Tangent, Okay, tingnan natin, Tangent function tayo. So, tangent of 40 degrees. Para di kayo malito. So, we will be having the opposite of 40. So, that is 0.05378 all over the hypotenuse, which is the delta CV. So, you have now the vertical deflection at point C as divided by tangent of 40. Okay. So, you will be having here 0. Sorry, that's not tangent. Butcha. Okay. That's not tangent. This should be sine. Okay, it should be sine of 40. Okay, so that's 0.05378 divided by sine of 40. Okay, or it's around 0.0837 inches. This is now the vertical deflection of point C on the figure. Okay, so that's it. Copy. Okay, so let's have this. The rigid bar AB attached to aluminum and steel rods is horizontal before the load P is applied. Find the vertical displacements of C caused by the load. Use P equals to 50 kilonewton. Neglect all the weights. Okay? So, pwedeng gawin natin. Kunin muna natin lahat ng reaction. So, you have here reaction. Tawagin natin yung TA. And then ito, tawagin natin yung TB. Okay? So, pwede kang mag-moment at point A, no? So, summation tayo ng moment at A. And that should become equal to 0. So, clockwise would be positive. So, P is 50. So, that is 50 multiplied it by 3.5 minus TB multiplied it by 3.5 plus 2.5. So, that is 6 equal to 0. So, you have now the TB is equal to 50 times 3.5 all over 6. So, that is 29.17 kilo Newton. Okay? So, that is 29.17. Okay? So, pwede na ako ngayon mag-summation forces. Vertical equal to 0. So, upward is our positive. So, I could have it TA minus 50 plus TB, which is 29.17 equal to 0. So, I will be having here the TA. So, 50 minus 29.17. So, that's around 20.83 kilo Newton. Okay? So, makukuha natin ngayon yung both deformation. Pero ang hinahanap kasi natin at C. Okay? So, kunin muna natin yung deformation at A at deformation ng B. So, I will be having here the deformation at A. So, that is equals to TL all over AE. Okay? And this is from the A. Okay? So, we will be having here the T. That is 20.83. Kaya lang gawin natin kilonewton. So, times 10. Gawin natin newton. So, times 10 to the 3. So, ang L niya is 3 meters. So, gawin natin millimeters. So, 3,000 mm. Para ang resulting natin is in mm. All over. Ang A natin, so, ayun, naka mm squared naman na. So, you will be having here 300 mm squared. And then, ang E natin is naka gigapascal. So, gagawin natin yung megapascal or newton per millimeter squared. So, imumultiply natin ng 1,000 or times 10 to the 3 para maging megapascal. So, you have now the deformation at point A. So, 20.83 times 10 to the 3 times 3,000 all over 300 times 70 times 10 to the 3. Okay? So, you have a deformation of 976. Okay, 976 millimeters. Okay? Same thing, I will deform deformation B. So, ang P naman niya, okay, that is 29.17. 29.17 times 10 to the 3. Ang L niya is 4 meters or 4,000 millimeters. Okay? All over, ang A natin is 500 mm squared. And then E is around 200 times 10 to the 3 para maging mega pascal. So, you have now deformation at B. 29.17 times 10 to the 3 is 4,000. 500, 200 times 10 to the 3. Or you will be having here 1.167 millimeters. Okay? Okay. By inspection, titingnan natin mas malaki yung ibinaba ng A sa C. So, in short, Kumbaga ito, bumaba to at this point hanggang doon. So, I will call that as N prime. Pero ito, bumaba lang to at this point. Tawagin natin yung B prime. Okay? So, meron yung dalawa. Okay? Yung pagbaba na yun. Okay? So, yun na yung naging ano niya. Ang kailangan kong malaman, if this is the C prime. Okay? Ano yung aking delta at C. Okay. Now, para ka lang ulit magre-ratio and proportion. Kasi ito, mula dito hanggang doon, this is already what? Automatic yun, yun yung delta B that is 1.167 mm. Okay? And then ito, let's have it the Y value. Okay? And then this is 2.5. Okay? Now, itong distance natin na to, okay, i-drawing ko na, medyo magulo na doon. Okay. So, magaganyan. Okay. So, ito na yung point B. Ito yung point A. Ito yung A prime. Ito yung B prime. And then, ito yung kailangan nating malaman. So, we will be having here C prime. And then, this is the C. This distance is automatic 1.167. Ano? 1.167. 1.167. Ito, that is 2.976 minus nung answer. 2.976 minus 1.167. That's 1.809. Okay? So, i-check natin. So, kailangan kong makuha yon by the deformation. Unahin ko muna to, yung malaking triangle na to sa ilalim. So, I will be having here 1.809 is 2. Distance niya in total, which is 6. Deformation, I will call it as Y. Okay? And the yung kanyang X distance is around 2.5. So, your Y should become equal to 1.809 times 2.5 all over 6. So, you have 0.75375 mm. Therefore, ang aking deformation at C, so that would be 1 point, itong buo na to, no? Itong buo na yan. So, that is 1.167 plus Y. So, 1.167 plus 0.75375. So, ang deformation mo sa C is equal to 1.921 millimeters. So, ito yung kanyang deformation. Okay? So, again, mahalaga yung ating ratio and proportion in solving most of the mechanics problem. Kopya.